RF jumper cables are part of our cellular DNA. Unless expertly made, jumpers often become a source of PIM. Soldering is one of the principal problems. Even the best technicians in the world can't provide a solder joint that isn't disruptive to RF signal linearity. It is quite common for jumper leads which have passed the factory or installation PIM test to fail miserably 2 weeks later. Here is a solder joint interconnection cross-section showing typical imperfections. Too much flux or unevaporated flux will cause a solder joint to crumble over time, causing PIM. Too little flux and the joint will be cold, vulnerable to cracks and result in the same problem. Each separation between solder and a contact or cable conductor provokes a distortive signal modulation and reflections, which promotes nonlinearity and reduces SNR. Hughes' clean joint induction technology provides very precise control over heat, time and power. The process is highly repeatable, so results are not dependent on operator skill. Hughes' clean joint technology improves process efficiency, localizes heat to the solder only, controls time and temperature, produces low oxidation, is non-contaminating. Eliminates heat-related dielectric distortion and metallurgic changes. Molding is an essential process to conserve a jumper's solder joint and to keep it gas tight. But high temperature molding can also result in a poor outcome for cables too. Dielectric, oversheath distortion and some metallurgic changes in copper conductors regularly occur, but go largely unseen when the temperature is too high. These subtle changes impair impedance, causing mismatches, signal reflections and harm SNR. Hughes deploy low-temperature molding techniques to conserve material integrity and matched impedance.